Hi guys, in this video I'm going to show you the basics of inverses and I'll show you how to find some inverses algebraically of a function. But I want to make sure we have a solid foundation and understanding of this. So an inverse function, or two functions are inverses, if their algebraic properties undo each other. So what this means, and we'll figure this out later when we get to compositions, but when I plug one function into the other function, these two, every algebraic operation, multiplication, division, exponents, addition, subtraction, will undo each other and then leave me with my original input. So basically, starting off with the coordinate points. If I look at the coordinate points, so let's start off by looking at what inverse coordinate points mean. What does it mean if two functions are inverses? How does that affect their coordinate points? So basically, remember, they're undoing each other. In this case, when we look at inverses and coordinate points, the x, y in the original, let's say this is the original coordinate point, which is some random coordinate point x comma y, then the inverse coordinate points will invert those two values. So x comma y becomes y comma x, where my new x value is the y value of the original, and my new y value is the x value of the original. So they are swapping places. Okay? So since it's the case that xy inverted becomes yx, where we switch the x and the y values, if I have this table where my original table has x and y coordinates of 0, 2, 3, 5, 8, 11, the inverse of this table, the inverse coordinate points of this table would be, my first inverted point would be 2, 0, where I flip the x and the y. My next one would be 5, 3. And my last one would be 11, 8. So a lot of students think inverse means switch the sign. No, that doesn't. The signs remain the same. All we're doing is flipping the order. 0, 2. Now 2 comes first, then 0. 3, 5, 5, 3. 8, 11, 11, 8. And again, I want to mention real quick, reiterate, remember, my inverse, these are my new x values and my new y values. So my original were originally 0 and 2. My new x value is now 2. My new y value is now 0 once I invert that point. So we already know inverses, the coordinate point flips from xy to yx, my new x value being the old y value, and my new y value being the old x value. With the table, we've seen some examples, and graphically. Graphically, when I put all this together and compare the original with the inverse function, they should display symmetry with respect to the linear function y equals x. So if you remember, and if you've been studying, the function y equals x is the parent linear function. And that is where it's going to display symmetry. Okay, so we have this function, and we know some coordinate points on this function. I've highlighted them here. This is my original function that we're going to go ahead and find the inverse of. So I have gone through and I've listed the coordinates for each one of these coordinate points. So what we're going to do now is we're going to take the inverse of these coordinate points, plot them, and then we're going to see the symmetry with respect to the line y equals x. So again, I'm going to go ahead and start with this one, and I'll do the rest on my own. So negative 4, 0 becomes, if I swap those, 0, negative 4. Negative 1, 2, 3, and 4. So that would be the inverse of this coordinate point here. So once I have done that same thing for each one of these coordinate points, this is what I end up with. So now all I got to do is I want to go ahead and connect these dots, and I'm going to use a different color, and then we're going to see the symmetry. So here is this is what we get when we connect the dots here. So the symmetry should be symmetrical with respect to the line y equals x. So let's see what that looks like. The line y equals x is a linear function with a y-intercept of 0 and a slope of 1. So I can graph this up 1 over 1, and I can put little tick marks. And I usually do this in a dashed line to indicate that this is not part of the function, but this is the line of symmetry. So as you can see, if I were to fold this paper in half along this line y equals x, I would get these points overlapping each other. We also see that they are the same distance from here to the line y equals x as their inverted points. So same distance from -4, 0 to the line as 0, -4, the inverted points. So this is what the graph of an inverse function looks like, where this function here is my original function, let's call it f of x. And in order for me to represent the inverse function, I keep the same letter that I called the function, but I put a -1 in the exponent. So f minus 1 of x is the function notation. So that -1 lets us know that we're talking about the inverse of this function f. All right, so we've already learned quite a bit from inverse functions. Just to recap, we learned that the coordinates of an inverse function, the original xy, the inverse would be yx, where they swap. Same thing with the table. If I have coordinate point 0, 2, the inverse would be 2, 0, 3, 5, inverse would be 5, 3. So this would be my new x and y values. Graphically, we just figured out that they display symmetry with respect to the line y equals x. So we looked at what happens when you switch the x and y's and how they compare to the original. And now let's just recap the notation. So earlier I said if I have a function f of x and I'm looking for the inverse notation would be a -1 in the exponent. So exponent with a -1. So if I wanted to find the notation, if I wanted to write the notation for the inverse of f of x, I would write f inverse with the -1 of x in the exponent. Same thing with g of x, g with the -1 in the exponent of x. And then h of x, h with the -1 in the exponent of x. So everything that we've just learned about inverse functions is great, but for your homework assignment, you're going to need to find inverse functions algebraically. So to do that, there are 3 simple steps that I will write out, and then we'll work out a couple examples. All right, so the first thing you want to do when you're solving, or when you're finding the inverse of a function, algebraically, is you want to switch your x and your y. And if there are multiple x's, you swap them out with multiple y's. Second thing you want to do is solve for y. So that's what you're going to solve for y. And then you're going to get y equals some equation. That new equation is your inverse function. However, all you need to do is apply the correct notation. So if your original function was f of x, you'd then swap out y with f inverse with the -1 of x. Or g of x switches to g inverse. So 3 is just like a notation thing. No real work there. All you're doing is putting the correct notation, labeling the new function correctly. So we'll start you out with the basic, easy one. We have f of x equals 2x plus 5. So and step 0 that I did not mention is we want to see, well, where is the y? Our first step is to switch x and y. I only see x and f of x. Well, guess what? Remember, f of x is the same thing as y. So if you need to, you'd go ahead and swap that out and say, well, I'm going to say write y instead of f of x. They mean the same thing. So step 1 is now I'm going to take this x and switch it out with y, and then take this y and switch it out with x. So once I switched out y with x and x with y, my new equation becomes x equals 2y plus 5. So now what I'm doing is I am solving for y, which is right there. So I would just use the same algebraic properties that I would use when solving for a variable. So first thing I would do is I would subtract 5 from both sides. And I'd say x minus 5 equals 2 times y. And then lastly, I want to get y by itself, so I would divide the entire equation by 2. So divide both sides by 2. And then I'm just going to flip it. Once this happens, I get y by itself. And then I'm left with x minus 5 over 2. Okay? So that would be step 2. Step 1 right here, we did it here, check. Step 2, we found the inverse of the function. So y equals x minus 5 divided by 2 is my inverse function. The last thing I want to do is apply the correct notation. So since I started with f of x, I'm going to have to go back here and switch y with f inverse of x. And I have completed that last step here. We already did all the work leading to my inverse function. All I had to do was switch the y with f inverse of x. That would be the correct notation. So this is the inverse function to this. So in my next example, I'm using g of x now, and g of x equals 4x squared minus 8. So again, what I want to do is I want to recognize that g of x is the same thing as y. That's like step 0. And now I'll go ahead and apply step 1, switch x and y. So I'm going to swap this for x, so there should be x equals 4. Swap this for y, y squared minus 8. So remember, what you're doing is you're solving for y first. So you would think, I need to get rid of everything outside of y. Well, what's immediately attached to y? The square. What's attached to that? The 4. What's not attached at all? The minus 8. That's what I need to get rid of first. So I would add 8 to both sides. So x plus 8 equals 4y squared. Next, I want to look at y squared and the 4 in front of it. What's more attached? The exponents are always going to be more attached. So I'm going to divide by 4 on both sides to get x plus 8 divided by 4. No, I cannot simplify 8 and 4. We talked about that in class today. But I get x plus 8 divided by 4 equals, and now I just have y squared. So my last step that I'm going to have to apply is to solve for y, get y by itself by eliminating that square. So how do we get rid of a square? Well, if I am thinking about opposite operations, I knew what the opposite operations were here. Plus 8 divided by 4, those are the opposites of subtracting and multiplying, right? So what is the opposite of squaring something? Well, the opposite of squaring something is square rooting something. So I'm going to tell you this now. We'll talk about it more later. But when you square or root something, remember you always have to put a positive and a negative sign in front of it. So a plus minus, just like in the quadratic formula. So when I square root this, I have to put a plus minus in front of it. Okay? So my final answer, once this square and this square root cancel each other out, leave me with y equals plus minus in front of the whole thing, square root of x plus 8 divided by 4. So I solve for y, that's step 2, check. The third step, I don't want to forget to go ahead and change my notation. So I'm going to rewrite y as the inverse of g. So g inverse of x equals, and then just copying the rest down. Now, if you're wondering, yes, you can simplify this. To simplify this, we could split it up into 2 fractions. Before I just simplify that, I can't simplify 8 over 4 the way it is right now. I'd have to split it up into 2 fractions. So if I do that, then I'm going to get square root of x over 4, which I cannot simplify there, plus, and then I can take 8 divided by 4, which is 2. So either of these functions are the correct inverse function. This one's just a little bit more simplified, and hopefully you caught on to it. Remember, just like in the quadratic formula, we can break it up into 2 fractions, x over 4 and 8 over 4. X over 4 cannot be simplified, but 8 over 4 gives me 2. So that's how I get to that last simplified answer. And now for our final example. So now we have a square root of 13x minus 10. We want to find the inverse of it. So what I again would do is I would write that y equals, in case I don't see it. You can always jump straight to that first step, if you can already see that, where you switch your x and your y. So I'm going to switch this y to an x, and I'm going to switch this x to a y. So that should be my new equation. Now keep in mind, when you're doing these square root ones, make sure the square root covers what it's supposed to cover. So in this, it covered the minus 10, so I need to make sure I'm extending it. All right? So now, much like the previous one, I want to get rid of everything outside of the y. Well, where is the y? It is inside of this square root. So I want to get rid of everything outside of this parentheses, if you will. In other words, I want to get rid of that square root first. Well, how did I do it on the last one? The last one, I was trying to get rid of a square, and I got rid of the square root. I used the square root to do that. So now I'm going to go the opposite way. I'm trying to get rid of a square root, so I'm going to go ahead and square both sides. And although we don't have to put parentheses over here, because it's just x by itself, it helps to get into the habit of that. I'm squaring everything on the left. Right now it's just x. So I'm left with x squared equals, and then the square and the square root cancel each other out, and leave me with 13y minus 10. Now it becomes a pretty easy problem where, I look at y, what's attached to it, what's immediately attached to it, 13. So I got to get rid of that minus 10 first by adding 10. So x squared plus 10 equals 13y. And then my final step is to divide both sides by 13. So when I do that, I'm left with y equals x squared plus 10 over 13. Oops. Now, you might be thinking to yourself, like in the last one, can I simplify this? Well, let's ask ourselves that. I can split this up into two fractions, x squared over 13 and 10 over 13. When I do that, can I simplify 10 over 13 any further? No, I cannot, so it is kind of pointless to simplify this one. But the last step, again, I want to make sure I use the appropriate notation. Since I started out with h of x, my appropriate notation would be h inverse of x would be how I would write it. So x squared plus 10 over 13. Nothing else changes. So that is how you would find the inverse of a function algebraically. So quick recap. Remember, an inverse is, if two functions are inverses of each other, they essentially undo each other. What does that look like? The coordinate point xy switches to yx, where the new x value of the inverse is the old y value of the original, and then vice versa. What does it look like on a table? Well, I take my table, my x and my y's from my original, I switch them, and now my new x's are my old y's, and my new y's are my old x's. What does that look like on the graph? Well, when we plot the original and the inverse, when we swap those x and y's, it looks like a symmetry. It has symmetry across the line y equals x, the diagonal line with the slope of 1 passing through 0, that parent linear function. And finally, algebraically, we're kind of putting all that stuff together, where first we would switch your x and y. That's what we did with our coordinate points. Then we'd solve for y, and then we'd apply the notation, which is that minus 1 as the exponent. So I hope this video helps you with your homework. I hope it helps you understand inverses a little bit better, and we'll be talking about inverses throughout the semester.